First of all, I would like to thank 𝐻𝐿 Palma for inviting me and for organizing such an important event that joins so many protagonists of the sector. My name is Angelo Palma, and I deal with pilot projects. I'm part of the Development and Digitalization of Processes group. Last year, during the Smart Grid Days, we promised we would talk about the experience of installation of a smart regulator in a REMI cabinet. So now I would like to summarize the main points of my speech. I will introduce my company, first of all. Then I will give you a description of the smart regulator. The pilot project is in Casa Massimo. Then I will talk about the results of our tests. And then I will talk about the next developments, so the ongoing projects. So 𝐦𝐻𝐿 is a company that operates in the natural gas sector, specifically in the gas distribution area. We are the second national operator for a number of PDR, drop-off points, and we are talking about 5.3 billion cubic meter of gas transported. We are present in small municipalities and large cities, and we have more than 2,000 employees. These are the main points of our company. To be close to the community, we are divided into 6 area departments that cooperate with these headquarters in Milan and the 23 territorial areas. Here you see our mission. We provide a service, a public utility service. So our aim is constant improvement through digital innovation. That is a fundamental element also as regards environmental sustainability, because the digital transition goes hand in hand with the energy transition and environmental sustainability of our activities. Here you see our 3 main strategic objects. First of all, consolidating the sector as a reference point, as a distributor, through autumn calls for tenders and the acquisition of other utilities. We are an aggregator of several bodies. Then we have as another objective the investments for the network and the digital innovation. We're talking about digital meters, software and hardware platforms that allow us to promote energy transition, creating networks for other gas rather than natural gas. We have 5 plants connected to our distribution network, and we have done some projects with hydrogen, with the stationary meter, for example. Here you see our networks, 72 kilometers of network, about 100 in high pressure, 30,000 kilometers in medium pressure, and more than 40,000 kilometers in low pressure. Here I emphasize the medium pressure because the smart regulator in the REMI cabinet allows us to manage our network in medium pressure. Here we see the typical plants. We manage 1,278 REMI cabinet, which is the fundamental plant for natural gas distribution, because it clearly separates transport and distribution with the change in pressure. We manage 17,000 reduction units, and in order to prevent corrosion of metal conduit, we have more than 4,000 cathodic protection plants. So this refers to traditional plants. Whereas if we consider the digitalization issue, for example, remote alarm plants, we have more than 11,000 plants that allow us to monitor remotely all our REMI cabinets and most of our reduction units. Then we have 2,700 sensors, and then remote measuring plants. We're talking about 1,600. This to give you an idea of the asset that we have to manage and the effort that it takes for their digitalization. Now, to conclude, here you see our company profile. The digitalization area is responsibility of Mr. Dalla Gussa. Now we have a new functional area, the digital room, followed by Francesca Francavilla, who's here with us today. We are a very lean structure, very young. We have three main headquarters, Milan, the lab in Cremona, and then 𝐒𝐻𝐢 near Bari, with 21 people in our staff. We have several pilot projects, some scouting activities, some standardization of and remote control areas, electronic meters. Now, before talking about what we mean by smart regulator, I would like to analyze the present situation, because if we look at our business as usual, that is the situation today, how REMI cabinets are managed today, our exit pressure is fixed and constant regardless of demand. So regardless of daily fluctuations, weekly ones or seasonal ones, we set the regulators with a fixed set point. The set point is a very cautious one, because as distributors, our main aim is to guarantee continuity and safety of the service. However, this kind of cautious approach may lead to overpressure, which is not necessary, especially in lower consumption times. And if we can reduce it, we can increase our efficiency. So smart regulators in this case can be of great help in regulating pressure, not in a manual one, but in a dynamic one, in an automatic one, based on real demand of our network. So you see the curve in yellow. The set point is no longer a fixed one, it's a variable one, that from a qualitative point of view is higher when we have higher consumption and is lower when demand goes down. This allows us to reduce excess pressure with a lot of advantages concerning the reduction of fugitive currents and emissions and the optimization of the measuring system according to the 512 law. So based on all of this, we decided to carry out a pilot project using the REMI cabinet in Casa Massima near Bari. The smart regulator was installed in October 2023, at the end of October 2023. Here you see the main characteristics of the cabinet. It's a cabin that has 2 regulation lines, and the measuring pressure is 4 bars. Please bear in mind this value because it will be necessary to understand how the cabin works. Here you see the different types of solution because the solution that we chose is adapted to the existing pilot. So the pilot has the aim of optimizing the measuring system following the 512 deliberation, and therefore reducing economic losses and improving safety and environmental impact by reducing pressure. Among the different solutions available on the market, we chose the 𝐬𝐿EM0. Here you see the installation area. Here we see the brain of this system is an RTU with the backup batteries, with all the electronic elements that communicates with the actuator that is present in the 𝐸𝐻𝐿. Here you see the source, which is the fiscal calculator. In the 𝐸𝐻𝐿 area, for each regulating line, we have an electromechanic actuator, a 𝐬𝐿EM01, that works on the pilot screw, simulating what an operator would do in the field. So it's not an adjustment that is done twice a year, as it was in the past, but a dynamic kind of adjustment that is potentially continuous. In order to do this, we need also pressure data. So we have 2 pressure transductors for each line. Here you see some pictures of the installation. Here we see the HMI panel that allows you to monitor parameters, the different parameters. Here you can see the cable line that allows us to supply power and transmit signals to the mechanical actuator, the golem. Here you see a picture of the golem that adapts to a metal device that connects to the pilot. As for the flow data, we have a 2-channel calculator and the pressure data from the pressure transductor. Now, before talking about the advantages of this solution, I would like to share with you how the REMI cabinet used to work before the smart regulator was installed. Here you see a graph of flow and pressure. Here you see in orange the pressure and in green the flow. Here you see the standard functioning of a summer period, low flow in October, so the week before installation of the smart regulator. As you can see, the pressure, the exit pressure of the cabinet was fixed at 4 bars, whereas flow may vary depending on a pattern based on a morning-evening peak with low flow around midnight. At midnight, we generally had problems because we had an average flow that was below the threshold. And so that was a problem. 2023 was a year in which there were no sanctions applied, but we made some simulations to try and understand how to reduce them. That's why we started this project. So once we've seen the REMI cabinet, let's see how it works now. Here you see the same graph, flow and pressure, for the winter period, which is a more critical period compared to summer. So setting needs to be extremely effective and needs to guarantee continuity and safety of the service. We've carried out a fine-tuning activity of the main parameters that led us to this solution. Here you can see that compared to a situation in which you had fixed pressure throughout the day, regardless of flow, now the situation has changed. We have two moments, a daytime range with a 4-bar level, and the nighttime range where pressure is 2 bars. The nighttime range, well, the set point was defined following several analyses. Here I would like to share with you the main parameters of the system. Let's see the situation on a typical day. So we have two different periods. At 5, the system reads pressure and makes several checks about pressure, that pressure is stable, that flow is sufficient, and so on. And then decides that they need to increase pressure. So pressure moves from 2 to 4 bars. It is done very slowly with 3.5-second movements. We do it because we want to avoid overflow that may cause problems to the meters. So with gradual steps, 3.5 seconds each, in 1 hour and 50 minutes, we reach the 4-bar level. Then the system stays alert and checks that we're getting out of the deadband. At 9:45 p.m., pressure needs to drop from 4 to 2. In this case, the drop is done quite rapidly. And why is it so rapid? Because maybe one would think that a gradual step approach would be better. Well, initially we adopted the gradual approach, but a slow reduction led to out-of-range downflows that were fake. So we decided to speed up things. So to summarize the characteristics of this golem system, it works with calibrated steps. It's possible to have a difference between the increase phase and the decrease phase. It checks constantly pressure and flow. And this kind of system, which is an add-on system that doesn't change the standard working of the system, acting on both regulating lines, allows us to maintain the calibration. And then, of course, the system has different methods to do all the settings. So we have mechanical characteristics. Regardless of the time, the system goes back to the initial conditions, that is 4 bars. So when the flow is higher than 80% of maximum flow for that meter, and without primary power supply, when one of these two conditions happens, the system goes back to 4 bar, regardless of the time. And then there are alarm signals, of course, that allows us to react immediately in case of an anomaly. And then we have mechanical safety systems. So we have physical obstacles that prevent pressure from going beyond 1.8 bars and over 4.10 bars. Now, let's talk about the results. The 5112 law was a kind of a shock for us as distributors. So as for the KPI on the rangeability of the meter, we know that we have a certain range. If we exceed that range, there are sanctions that are based on the flow and the hours. So based on these two parameters, we have measured the performance of our smart regulator system, comparing it with the standard system. So we imagine that for the observation period, the pressure was constant at 4 bars. So we have 39% reduction of flows with potential sanctions. In summertime, July and June, see a 48% reduction. And in May, we work for 24 hours with 2 bars, and this is a great result because traditionally we would maintain 4 bars. So I think this is a great result, regardless of the reduction of hourly flow. And there's been a 19% reduction in the number of hours that are potentially subject to sanctions. So very excellent results that make us hopeful when it comes to next projects. Let's now talk about these next projects. We have the 404 project that is financed by ARERA. Automa is a supplier of a technical solution and is also a system integrator within this project. So we will be working there for 3 years, monitoring the reduction of fugitive emissions. This reduction needs to be measured in different conditions for 4 cabinets. 2 are in pool conditions, introducing also predictive calculation algorithms and AI. So 2 additional steps compared to the previous project. The Casa Massima project was an aerial cabinet. In this case, there is an evolution with the integration of artificial intelligence. So our tests will involve Automa as well as other suppliers. Then there is another project called Ambito Napoli for the installation of smart regulators in all there are 6 REMI cabins. We increased the size of the plants. One of them has 3 cabinets supplying it. And as for BioREMI, we have a smart regulator system that acts as a flow regulator valve. So by the end of the year, we'll have 12 REMI cabins and 29 regulation lines, totally automated. And this will help us reach our objectives in terms of environmental sustainability and increased efficiency. That is all from me. Thank you very much for your attention.
I've been presenting the situation for the GoLEM regulation. That's the GoLEM system.
GoLEM?
You probably know me as Mr. GoLEM. And this year, we're going to continue talking about dynamic regulation, injection of renewable gases in the networks. There are new challenges for gas distribution networks that basically come from the use of renewable gases. Before addressing this topic, we first have to address the way that networks operate at a European level. They operate in line with European regulations. We have here a picture, and this picture shows that there is a gas distribution network. Gas distribution companies buy gas in international markets, and they inject it in the system through at specific points, at specific input points with LNG or through ships. They are active at international level. In Spain, for example, there are 4 moments in which they are put into the networks, Argelia or through the Pyrenees, so from France. So this way, the gas is distributed, is brought into the system. There is a technical operator managing the system. It receives the gas that they buy from the distribution companies. They stock it, then they regasify it and enter it into the system up until the drop-off points of companies, of distribution companies. These distribution companies then, in turn, distribute the gas throughout the country, and users receive it through their gas distribution companies. So basically, they receive it from the companies, they pay, and then these companies ultimately pay the technical operator of the system. The role of this technical operator is particularly important because it basically informs the entire system, the entire industry, about the chemical and physical characteristics of the gas that is being distributed through the networks. And it also has the task of the hydrogenation of gas, and it also reaches the drop-off points. Up to this moment, there was not any other injection point other than these ones I've just mentioned, other than the technical manager. Given the fact that we now have renewable gases that are distributed at the moment, up to this present moment, we had lots of doubts about the chemical and physical characteristics of these gas mixtures. And so now we're going to have a look at the experiences we have made so far in dynamic regulation at the level of traditional gases. In Spain, we have made experience in this field soon after the development of the Golem system, and these experiences were made in, for example, in Zaragoza. There we had a problem, and this problem brought to problems in the meters, to the break of the meters in the moments, in the points in which gas was injected in the network. So there was problems in terms of meters being undersized. Because of this smaller size, there were problems, and the gas meters would break down, and this in turn would limit consumption. The introduction of the Golem meter provided for a balance at all the entry level of the levels of the gas, at all the entry points of the gas, and this prevented other problems with the gas meters to take place, to happen. With the latest model of the Golem system, the so-called Golem Zero device, We then made other experiences in Italy, and this in the field of the 2E gas network in Mantua, and this to reduce fugitive leakages, fugitive emissions, and prevent problems. The introduction of renewable gases brought about a change in the paradigm when it comes to the input, to the entry points of gas. So there is priorities when it comes to the availability of methane that has to be entered into the network. There is also a secondary effect of this linked to the limited production capacity, because there are very few entry points, and all of them have a very limited flow. This has a negative effect, namely the fact that there is not so much certainty in terms of the quality of the gas in the network, the variability of the PCI, and also doubts concerning the composition of the gases that make up these mixtures. As regards hydrogen blends, there is also the problem of the variability of the PCI. Another secondary negative effect that has to deal with the role of the systems technical manager consists in the fact that in the distribution of the gas, transport has to be done with a low volume of gas. Here you see an interactive map, and you see the density of the entry points of biomethane in the networks. In Spain, we are the very last in the development of this development points. So there are 9 points in which the biomethane can be entered in the net, but we can see that, for example, density in France is 680 entry points. So this means that we are currently still learning we are actually discovering what kind of effect the introduction of these renewable gases are bringing about to the network. In other words, we're dealing with a different situation, and there are some problems and challenges that need to be solved. These negative effects that we were talking about have a repercussion when it comes to the management of the networks. The first one concerns the priority when it comes to the introduction of biomethane. The prevalence of having biomethane accessing the network tells us that this is something that can happen. There are pressures that are very close to the operational maximum level, and so there is some gas left. The introduction of entry points in a system that is already saturated, because as a matter of fact, we don't have such, there may be moments in which consumptions are not very high because of the season, for example, or because of the price of gas, may lead to the saturation of the network. And so because of this, you may have some gas, some spare gas left. Then you may have multiple introductions of low flow, and this may lead to difficulties in cases in which you have devices without dynamic regulation. This may lead to problems when you have, for example, small consumption, and this may lead to stop it in the emission because the pressure regulator has these problems. We also noticed that the gas composition is variable, and this may bring about problems for industrial users who not only use gas as a product for burning purposes, but also as a raw material. For example, for the processing of melted copper or for other chemical processes. Then the introduction of a hydrogen blend brings about unknowns when it comes to the calorific power of the networks, because you don't have a homogeneous situation, and there may be areas in the network where you have a very low level of PCI, and other areas in the network where you have a higher level of PCI. At the same time, the spare gas in the networks has another important problem, which is the fact that transportation networks may have a lower flow. So we've tried to provide an answer to these problems. So we first proposed some problems to solve these problems. So, for example, to solve the problem of spare gas in the networks, we have a reverse flow system. So this is a mechanical system of gas compression that takes the spare gas and introduces to a higher level network that has the capacity to accommodate this spare gas. When it comes to the difficulties in the cases in which you don't have dynamic regulation systems, we propose the Golem 0 in these cases, because we try and, in a way, fix this priority. Then, in order to correct and make up for the variability in the composition of gases depending on their origin, especially because of the many problems that this issue gives to production, to industrial production, we try and increase the tests and the analysis that we carry out in industrial areas. And in order to solve the problem of the uneven calorific power in the networks, we are currently investigating another solution in the various countries. We're trying to envisage whether the limitation of the percentage may be a way to solve the issue. When it comes to the problems of the meters in the transportation stations, natural gas transportation systems, we offer dynamic regulation with Golem 0. So here you see our proposed solution to one of our main customers, Nexia. This is a gas and methane distribution company. Here we presented the Golem 0 that is certified for the introduction of biomethane with a homologation system. This product is now homologated. We managed to solve this issue, and the issue basically consisted in optimizing the injection of biomethane. In this situation, and this happened in the situations in which introducing gas may lead to problems in the upgrading. And this can be solved by reducing the flow, precisely because we acquire the data and we then kind of modulate the flow. We also try and solve problems related to the increase in the network. And in that case, we basically increase the flow, thereby increasing also the regulation set point. The other two problems that can be solved with our system refer to the limitation of the introduction of gas to nominal values as indicated in the contract. So when we have a customer that proposes for the introduction of biomethane, we are forced to kind of introduces biomethane, and so there is a maximum level that we need to respect. That is something that we cannot that's a value that we cannot overcome, that can lead to a problem when when you have spare methane. So in that case, we try not to overcome that contractual value. And then finally, we change the set point, the pressure set point remotely, as often happens, and we modulate pressure with the Golem system. Here you see a picture. That's actually a video that I can show. And here we show the process, the homologation process. This is a REMI cabinet of biomethane that's near Barcelona. Here we install the Golem system. Our customer adopted a secondary line, a spare line that is regulated in order not to modify the pressure. So here you see there is a screw, and in the upper part you see the Golem system. Let's have a look now at this video. Let's watch this video. As you can see, there is an Allen key here with a flag, and that tells us how we can observe the movement. There is a rotation, a clockwise rotation. So we simulated a pressure increase, in the network. It's very difficult to make tests when you have to make them to increase pressure. So we do a simulation, and we really hope that everything works. In this case, Golem doesn't look like as if it were something extraordinary, but it gives this fantastic result. But it is indeed very effective. It is indeed effective. As I said before, the system is already homologated. We have 7 modules for the emission of biomethane with the NATO heat group. And here you see one of these systems. So, to sum up, as we said, we have a new management system for the distribution network. This model, as you can see, we have these new points for the introduction of biomethane, and they are increasingly closer to final users. So they can be used, for example, for commercial purposes. And this, of course, facilitates the fact that you have spare gas. So this brings about extra pressure, and in turn, this brings about with the implementation in various points of reverse flow systems to compensate this spare gas left. So that if they get saturated as well, through the system, we can invert the system to other networks, to other transportation networks. If you have underground stocks, you can use them, but you can reach the point in which the flow reaches 0 as a value. This already happened in electrical distribution networks. Self-consumption is providing for a situation in which the point where electricity is consumed is exactly the same point where it is produced. So the electrical distribution network done with lots of capacity have an intensity of circulation that is close to zero. In other words, we're talking about support networks, which are reserve networks. So we are not dismantling them. However, if there is a problem in which a certain production is present, we can still nonetheless send energy to the consumption point. In other words, there are transmission and transportation stations that this is something that is often asked to Spanish transporters when emission is very low and when the meter is not capable of detecting it. So in this case, with the Golem system, we provoke an emission of built-in gas, and this way we avoid the emission. We prevent emission from getting close to zero. So by lowering pressure to certain values, we reach this built-in emission. This is all as far as I'm concerned. I've tried to be as brief as possible, and I hope I haven't bored you. Thank you very much for your kind attention.
Our presentation will be a lighter one. I'd like to thank Angelo and Luis for their presentation that gave us a lot of food for thought. Manlio Mercanti and Andrea Giorgetti will be helping me in giving you this presentation. I would like to, on behalf of the Commercial Office, I would like to thank all of you for being here with us. Your numbers increase year after year. Tomorrow is going to be another very interesting day. We will talk about cathodic protection. So many of you will stay here, and we'll have the opportunity of spending time together and talking about these issues. Now, together with Manlio, I will try and summarize and give you a summary of the projects we have ongoing right now. Some of them have already been described this morning, like TEASEI and Angelo as well in the afternoon. Let's try and give and have a list of projects that we have started that are all that are ongoing in Italy and worldwide. I will start with the Italian situation, and then I will leave Manlio to... So, we will talk about the 𝐒𝐿𝐴𝐻 project, the smart regulator project. What is 𝐒𝐿𝐴𝐻? Well, we've already heard about it from Angelo and Luis. This is a system, a smart system, that allows to do some setup on reduction groups from first and second level cabinets. So dynamic setup of reduction groups. So it's a licensed technology. We have a patent for it, for the control of these kind of stations, using a servo mechanism. It is an electromechanical servo mechanism that couples with the pilot and makes any regulator controllable remotely. So pressure setup is dynamic and automatic. Now let's have a look at the general characteristics. ATEX zero zone certification. In the first project, we had an ATEX 1 certification. Now it's 0, because there are areas in the world that require also this kind of certification. Patented technologies, as we said, automatic setup, no venting. So in this case, there is no release of gases in the atmosphere. This is a very important point, especially if we talk about environmentally friendly. Plant retrofit, so we can adapt any plant. Operational safety, Angelo talked about the safety options that we have. This has been one of the most important points. And then high adaptability. So it can be adapted to any kind of setup system. Then we have manual setup. These are the options that we have. So manual and emergency setup, remote control. So the system can be controlled remotely, manually by the operator, or providing set points to the system. We can use our proprietary software, Modbus, IC104. Flexibility in terms of design, because each project has its own history. So installing a golem is not like placing an engine on a screw. There is a project that takes into account the different characteristics of the cabinet itself. And there are several areas and fields where it can be used. The first project that we carried out with the golem system is the simplest version of it. It was done in Italy. 𝐸6 already talked about this, about the giant project, and 𝐸𝐻 for the Casa Massima project. In this case, our partner was Italgas. So the GRF station received a remote control for pressure, 25 reduction groups. The aim was to increase and reduce pressure depending on needs of the plant. We applied the golem system on one line of the reduction unit. The other one is the service line. The RTU communicates directly with the Italgas center. And the result was the remote setup of pressure and partial digitalization of the grid. The setup management is not automatically done. The setup value is given by the operator in the control center to adapt the pressure to the needs of the moment. And then we have dynamic setup on GRF. This is a part of the giant project we talked about this morning. It was done in Mantova. I won't tell you very much about it, otherwise I'd be repeating things. So apart from the integration project, we adapted our golem system to different pilots that we found in the Mantua grid. So different types of pilots, and we were able to find mechanical solutions to adapt to the different systems and take control of the setup screws. So we have to thank our colleagues from the IT sector for what they did. We already talked about results, reduction of fugitive emissions, optimization of operational costs, and optimization of pressure on the line. This is the Casa Massima cabina Remi. Angelo talked about before, so I won't go into detail. You've already seen the graphs, so what we've been able to achieve. Surely the cooperation with the distributors has been a very positive one. We needed information, and we provided information to the company for the setup of the system. And nowadays, we are working with this setup with the results that Angelo shared before. So this is another success and has been going on for 1 year already. Dynamic setup on Remi with the DUI group. The project is called Neapolis. We're talking about 6 cabinets in the metropolitan area of Naples. We've installed the golem system. We need to start with the testing phase. And then we'll start working on dynamic setup by working together with DUI to optimize, because we need to fine-tune the values. That is a key phase of the system. We need to define all the parameters that are required to obtain the results we want to obtain. Then we want to create predictive calculation algorithm to simulate different functioning situations. Also, in this case, these are pool plans. So it's even more challenging in this case. This is again about Neapolis, so we've already talked about it. Here we have an important cabinet with 3 lines, so a real challenge, but we're working on it. And then the last project, it's a project we are already working on. It is in its testing phase, so the application of Golem on a biomethane cabinet. While with the Remi cabinet, we had a gas from SNAM at a fixed pressure, guaranteed pressure. In this case, the situation is not so guaranteed. So gas entering the cabinet is not so guaranteed. So we developed an algorithm to maintain a constant pressure so that before the reducer, we had constant pressure, and so that we could have a constant flow. Here you see the graphs that represent the setting up of the system. As for details, Andrea, who's the project manager, who can give us further information. In this case, we had a biomethane cabinet with great problems at the setup stage, and it started working. The algorithm that we developed focuses on this kind of application, but we were able to achieve the goal that we've set for ourselves. As for Italy, these are the projects that we have implemented.
No, al momento no, a meno di domande, poi Andrea è a disposizione.
Okay, now I leave the floor to Manlio, who will talk about the project that we have in the rest of Europe. Good afternoon. Thank you for being here. This is my first speech in Italian, so please be patient. Okay. We have some projects both in Europe and in Latin America. They are different kinds of projects, as you will see. This is the first one. Luis Castaño was referring to it. That is the standardization and homologation of the golem for the dynamic setup of biomethane. This is to avoid the distributor the need to compensate the producer. So in this case, we were able to achieve our goal. And we expect a purchase order very soon from Luis. A very direct message. And then, together with our partner, we will install in the fourth quarter the same type of project, the same as in Italy. For biomethane, the market is similar and very small. Also in this case, we are still defining things, so we still have to agree things with the customer. The aim is to maximize the injection of biomethane. And then we have another project for dynamic setup in Portugal for a reduction group. The aim is to increase or reduce pressure remotely based on the time of the day or needs. So we will use a cabinet with 2 lines. We have not defined which ones yet. And so we will allow remote setup of the cabinet. Let's now move on to the other side of the world, that is Mexico. We have 2 projects right now using golem. The client is naturally Mexico. So the first step is the dynamic setup of the valves. They have a problem, and that is gas leakage. Not like in Italy, a natural release of the network. This is a clandestine kind of activity. So the customer initially wanted to have a dynamic setup and obtain information on how the grid is working, and then being able to calculate this gas that is being stolen, and then eliminate this kind of leaks. Because, of course, we need to solve this. So we will install golem in 2 final reduction units with a single line. And then we have another project called the 𝐶ISE. Silvia Garcia had to make this presentation, but she cannot be here for health issues. This project aims at protecting the gas network in case of an earthquake, for example. So in the first step, the golem will simply operate the opening and closing of the valve with the command instruction in the 𝐶ISE system, which is in the office of the customer. In the second part of the project, or in the evolution of the project, all orders and commands will be done directly through the golem. We expect to be able to do this by November. And then we go to Patagonia, Chile. The customer does not have a gas network. So they have a gas, they want to create a gas distribution system. Right now, we're talking about 150 cubic meters per hour, but the turbine is not working properly. So the client suggested to use the golem to change the fundamental parameter, being able to calculate the gas production and transport. This project will start working at the end of 2024. Thank you for your attention, and if you have any questions, I'm here.
For other two talented speakers, I suggest that we start with Andrea D'Alessandro. He is a consultant of Automa. So we're closing the afternoon session with this fantastic experience he's going to talk about. This is the experience of two young people that Automa is supporting in their training. Allow me to kindly introduce Andrea to you. Andrea came to Automa for his MA thesis. He graduated in engineering, biometric engineering, and we talked about the possible impact of emissions of methane on human health. We thought that that topic was really very interesting because everybody's talking about greening actions and reduction of emissions, emission reduction. So we started developing a whole series of assumptions, of hypotheses on the application of the Golem Zero system on pressures and on the result. Actually, in a thesis, we talk about theory. We have theory, but actually, if you calculate mathematical formulas that you find in literature, you might anticipate possible effects on the health of human beings. I'd like to leave the floor to Andrea. Many thanks to Walter for his kind support. So good afternoon, everyone. I would like to thank Automa for this great opportunity. Automa gave me the possibility of carrying out my final apprenticeship for the preparation of my MA thesis. The title is The Impact of the Golem Technology on the Reduction of Methane Emissions Benefits for Public Health. The aim of my study was to understand and report the effect of climate change on man, and to investigate the correlation between health and methane emissions and global warming. We had two main objectives: to quantify the reduction of fugitive emissions thanks to the Golem technology and its operational features that were mentioned before. And also we wanted to investigate how and to what extent leakages, fugitive emissions, have an impact on human health. And that's basically, that very much pertains to my degree study, which is in biomedical engineering. So this is the structure of my thesis. In the first part, I developed in detail all the biological mechanisms that are related to climate change. So cardiovascular diseases and other types of conditions. In the second part, I focused on the natural gas supply chain in Italy. I addressed emissions at a global level and specifically in Italy, because that is the area that I mainly investigated. So I basically concentrated on Italy. And then the emission formulas of the emissions that I used. And then the third part is more computational. Here I talked about the way that the Golem system works, and I talked about the results for medium and low pressure. As I am a newbie in the field of natural gas, my study started with a deeper analysis of the gas supply chain, starting from the purchase of gas up to the distribution to the final user. I mainly focused on distribution to understand how the Golem meter could be used in that specific step. So I tried to understand how the REMI cabinets work and how the GRF devices work. So I analyzed all the various lengths of the network. I also investigated how the purchase, the supply of gas takes place through ships or the national pipeline network. Then the study continued with an in-depth analysis of methane emissions. Methane is the second greenhouse gas that is generated by man, the most abundant one after CO2. And in order to achieve the objectives in the Paris Agreement, so limiting global warming to 1.5 degrees by 2050 and to 2 degrees centigrade by the end of the 10th century, about 1/3 of methane emissions, of current level emissions, should be cut. And about 45% of these emissions, of methane emissions, should be cut by 2040. Why are we focusing on methane? Why are we talking about methane? The fact is that even if methane is the most abundant, the second most abundant man-made greenhouse gas, it has a shorter life cycle. So it can have quicker effects if combined with global warming. So it is a greenhouse gas, so it creates this greenhouse effect, and this increases the Earth's temperature. That is why this is methane's peculiar feature. And that's one of the most important aspects that were discussed during the Paris summit. And then I analyzed the main emission sources in Italy, on Italian territory. It was namely estimated that in 2019, over 1,718,000 kilotons methane emissions. Most of them they are seen from the pie chart, which shows all methane emissions from 1990 up to 2019. They're very similar. Most emissions come from agriculture, so animal breeding, enteric fermentation, and so on, and the disposal of waste. In these areas, we already have technologies that reuse these gas emissions in an effective way. When it comes to fugitive emissions, the situation is quite different. Fugitive emissions make up for 2% in the pie chart, but the ones that come from natural gas are 63%. And here we're not talking about limited quantities. In 2019, the distribution, the transportation, the storage of methane led to about 150,000 kilotons, which is a very large share of the pie. In my thesis, I also analyzed the impact of these emissions on public health. Global warming caused by greenhouse gases like methane and other gases leads to a direct increase in temperature and to an indirect increase in the levels of air pollution like ozone and fine particles, which, as we know, are harmful for human health. According to 𝐒𝐿, in 2019, due to the air pollution caused by the burning of fossil fuels, about 2,864 premature deaths were registered, over 1,500 cases of respiratory impacts on adults and children, over 4,100 hospitalizations, and over 5 million working days lost due to pathologies, to related pathologies. So you can easily understand that the increase in the Earth's temperature can bring about an increase in the effects on public health and the health system in general. Several studies have confirmed the impacts that global warming has on man's health. There was a study published by the Department of Clinical Medicine, Public Health, Life Sciences, and the Environment of the University of L'Aquila. This study showed that global warming has a negative impact on cardiovascular disease, including, for example, hypertension, diabetes, heart ischemic diseases, heart failure, and stroke. And the study analyzed a whole series of mechanisms that can be triggered through abrupt exchange in temperature, which can have an impact on cardiovascular diseases, cardiac arrhythmias, and atherosclerosis. As regards air pollutants, the World Health Organization declared that these are particularly harmful for human health. And after the WHO expressed itself in this way, the European Parliament and Council passed a directive on air quality and environmental quality, in which there should be an average number of hours during the day, an average quantity during the day of 120 micrograms per square meter, per cubic meters, an objective value and an objective, long-term objective value aimed at protecting human health, and then the regulatory obligation to reduce these emissions. So this was the background study that was done to study the application background, the application context of GoLEM, and to analyze the way through which GoLEM can bring about benefits in terms of fugitive emissions of methane, which are the ones that I mainly focused on. So in my study, I first quantified the intrinsic emissions, the fugitive intrinsic emissions, both in the average and in low pressure. And this was done through a very linear experimental methodology. At the beginning, I aimed at analyzing the flow that would come out from a generic leak. Of course, you can have different types of leaks. The diameter of the leak can vary significantly. And so we took an average. We took an average leak when it comes to the hydraulic average value of the leak. Then we calculated the average emission rate of a leakage, so the cubic meters per hour emitted from that leak. And then we made two calculations, one concerning the emissions of methane in 10 hours and annual methane emissions. The calculation relating to the 10 hours refers to 10 hours because we assume that that's the duration of time through which the golem device is functioning. So, and it regulates pressure. So starting from 4.4 bars to 3 bars. And 10 hours is the number of hours in which you may have, for example, more emissions. So there may be, for example, you do not calculate the hours during the night and the 2 hours during the day where the golem is not working. And then we made a calculation before and after the application of the golem device. This was quite a large study, and so I had to rely on assumptions to simplify my calculation. So, for example, the hydraulic diameter, the assumed diameter was 0.4 millimeters. We basically analyzed values available in literature, and we basically found out that that was the average hydraulic value mentioned. While when it comes to the density of natural gas to reference conditions, I calculated a value of 0.66 kilograms per cubic meter by using reference norms. So specifically the EN ISO 13443 of 2005. And the empirical formula by van der Waals, through which I was able to calculate gas density at the reference conditions and reference temperature, considering the temperature formula and the pressure indicated. Here you see the formulas I used. I found them in the document on the quantification of fugitive emissions from pipes. This is the formula that is at the basis of the calculation of these emissions. The first term is the volumetric rate, the time of emission that I assumed to be constant in the 10 hours. One thing I forgot to say, these are emissions which are intrinsic because they're very small emissions. So they can hardly be detected by cathodic corrosion. They are emissions through pitting. So in the surface and inside the pipe, well, the pipe appears to be intact, perfect, but as a matter of fact, it is damaged inside, and it is through these pitting areas that you have these leakages. And then 𝐻CH4 is methane concentration. And this is what I said before, the definition of the type of gas flow that comes out of a leakage, which may be supersonic or subsonic. Depending on the case, you have a different formula for the volumetric flow rate that needs to be calculated. And this depends on the ratio of critical pressure, which I assumed to be 0.54. using an adiabatic index of 1.3 for natural gas. If the ratio between atmospheric pressure and absolute pressure given by internal pressure, so pressure internal inside the pipe, plus the air pressure, if this ratio is higher than the critical ratio, we're having a subsonic flow. Conversely, we have a supersonic flow. This is yet another assumption. What you see here, these are the formulas for the calculation of volumetric flow, the reference legislation, the reference standard used, sorry. And here you see the results that I obtained for average pressure lines. Within the 10 hours, if you go from an internal pressure of 4 bars to 3 bars, you have a reduction of emissions of 32.7%, while annually we have a value of 13.6%. Then I did the same. I carried out a practical application through data that I found in literature. And here I assumed that in that given specific area, we could reduce pressure to even 2 bars during the day. If this is the case, it was estimated that reducing pressure to 2 bars within the 10 hours, you have a concomitant methane emission reduction of 50.7%. Annually, again, if you reduce to 2 bars, you have a reduction of 21%. And this clearly shows that Golem dynamically adapts the kind of network it is installed on. So it enables to have advantages in emission reduction that can vary depending on where it is installed, and always depending on the demand that is downstream the whole gas distribution system. What you see here are the results obtained for low pressure. So for 10 hours, a reduction of 23.62% in methane emission reduction, while annually we have a reduction of 9.84%. Again, assuming that the Golem can reduce pressure to 20 millibars for 10 hours a day. 20 millibar is again an average value between all the low pressure values that I found in literature, which vary between 23 millibars and 18. So we took 20 as an average value for this calculation. So by way of conclusion, here you see the results that I depicted in these graphs annually and within the 10 hours. We can say that these empirical calculations have shown that the Golem technology can represent a significant step forward for the improvement in the management of transportation and distribution networks of natural gas in an effective and efficient way. Thanks to its many advantages, the Golem system does not only contribute to the reduction of emissions and to cost reduction, but it also supports the adoption of innovative systems that can support the reduction of methane emission and therefore an attainment of the national environmental objectives. That was all. Thank you very much for your kind attention. Thank you very much. We have one last guest, Veronica Crognaletti from Automa, for her last contribution. And then tomorrow we're going to have a session on cathodic protection. So once again, thank you very much to Automa for supporting these young talents. Veronica, you have the floor.
Buon pomeriggio.
Good afternoon. My name is Veronica Crognaletti. I'm in charge of process control and the management of research and development projects in Automa. I would like to start with a question. Would you ever have thought that you could detect gas leakage when the gas is invisible using light? Well, Let's have a look at the situation. Problems concerning gas leakage in the atmosphere and environmental pollution and water pollution are becoming more and more interesting because they can impact the economy, society, the political field, and also our health and safety. So through data coming from scientific research, we understand that it's very important to start acting now. In this slide, you can see some figures that describe the future. Andrea has already described some of them. For example, the increase by 1.5 degrees of temperature by 2030, 2050, if we don't act now. About 35% of anthropic emissions of CO2 that are directly absorbed by the ocean. 126 billions of cubic meters that are gas emissions recorded in 2021 in the oil and gas sector. And then 99% is the percentage of the world population that breathes polluted air. And 2.7% is the global 2.7% is the amount of pathologies that are caused by indoor pollution. In order to investigate our leakage, spectroscopy is really helpful. You're probably familiar with it. It's a non-destructive technique that allows us to analyze the molecules directly. Using an electromagnetic radiation, generally it's a monochromatic one, it kind of creates a fingerprint of the molecule that can be studied. And it does it in a very simple way because we don't need to prepare the sample previously. And the spectroscopic techniques that are used, Raman spectroscopy and infrared spectroscopy, are more and more studied and applied in our projects. The spectra technology is a solution by Automa. It's a standard solution. It doesn't use Raman spectroscopy. It's a solution that has been designed by Automa to identify the concentration of odorant in the gas pipelines. What's the difference between spectra and the other solutions available? Well, spectra allows us to do a measurement in the field, so you don't need to take a sample of the gas. You can do the analysis right there. So the conditions are the best ones. Secondly, spectra works in a totally automated way. There's no need for one operator to be constantly there to supervise. And this is clearly a plus in terms of safety. It requires minimum maintenance and allows for constant monitoring. But this was not enough for us, so we decided to do something more. We tried to see what the future developments could be. So at the end of 2023, we decided to start two ambitious projects. The first one is the Hydra project. The Hydra project deals with hydrogen, not just hydrogen leakage detection, but also the study of the benefits and risks connected to it, so that we can develop monitoring policies that allow an effective use of this technology. It is an ambitious project because it's a European project. You see the Automa logo, but there are also other partners, Italian ones, like the Turin Polytechnic University, but also other European partners like Warrant, Cardiff, and Lancaster University. The Hydra project aims at increasing the use of a source of energy that is carbon-free, and does it through certain steps. An initial analysis of the policies, the market, and hydrogen emissions at present. Then it will develop a sensor to analyze in the field hydrogen emissions. And then it will work for mitigation policies to allow a safe and effective use of the technology. So what are the main aims of this project? First of all, the dissemination of this hydrogen technology through mitigation guidelines. And then monitoring tools, automated ones, continuous monitoring tools, and also the promotion of common projects, clustering projects in the European Union and beyond. Then the study of hydrogen impacts, especially looking at the environment, but also the socio-economic and political consequences. And then there will be dissemination to all stakeholders. Automa is already developing the core of this project, that is, sensors that will allow us to monitor the whole hydrogen value chain. In this slide, you can see the block scheme of our sensor. So there will be a sampling unit at first, with pipes connected to the main measuring points. And then an optical unit, the central unit, with Raman spectroscopy that will allow us to analyze the hydrogen. And then the data processing unit that will allow us to obtain data that can easily be used for the drafting of future policies. So this is a very ambitious project, and it aims at further development in the field of environment, emission and energy, everything that refers to safety, sustainability, climate, and political issues. Please go to the website and the social channels of the Hydra project, where you will see any update of this project. Let's now move on to the second project, that is the 𝐴𝐴𝐼-𝑊𝐴S. It's an Italian project. Automa decided to have partnership with local partners, the Polytechnic University of Marche and the University of Camerino. IWAS is a project that creates sensors with the Raman technology, but at the same time we're talking about artificial intelligence. So we don't simply detect hydrogen leakage or leaks, but assessing the quality of water and air. It's a very ambitious project, very important for our environment and our health. So constant monitoring of the composition of air and water. Also, in this case, the project has certain steps to follow. First of all, an analysis of the scientific literature to identify the main pollutants for both air and water, and then study and design of the sensors. This is the part that Automa will mainly be involved in. with the development of a dedicated sensor. And then there will be the prototyping part and the laboratory testing part in order to look at the future, because we don't simply want to create a sensor that allows us to do this kind of monitoring. We want to develop a family of sensors that will be usable in the future in other areas, in other sectors, that allow us to make headway with our research. The technology we are using, spectroscopy, fluid spectroscopy. We want to create a technology that is easy to use. We will use a low-cost technology that has already been used in the customer market, and we will adapt all our knowledge in terms of Internet of Things and artificial intelligence. We will use our technical expert in Automa and other research centers. As for the results we expect, they will look at the environment on the one hand, so attention paid to air and water resources, but also to human health. This will allow us to create a monitoring network that will be continuous and automated. In this way, all decision makers will be able to adopt solutions that will allow us to look at the future. So that is all from me. Thank you very much for your attention. I just would like to mention the fact that we're still looking at the future with the development of this technology also for the biogas. We have already just started a new project, so we are constantly evolving and looking at the future. Thank you. Thank you, Veronica, for this very lively conclusion.